the set of all solutions of the inequality log. So there is inequality given. We need to solve the inequality. Basically, we need to find the value of x. Okay. So here there is a log based inequality, and whenever we see a log based inequality, we need to know that if there is a log function and the base is a, so there is two condition that may arise. That is, if a is positive, that means the function is increasing function, and if a is less than 1 and greater than 0, the function is decreasing function. Okay. Now here see, here the base is variable. Here the base is variable, that is 1 minus x. So we need to make cases. We need to make cases according to the variable. So according to the base. So let's say case 1. Let's say the base is greater than 1, and the base here is 1 minus x. Let's say that is greater than 1. So that means x is less than 0. That means x is less than 0. Okay. Now for that case, the function is actually an increasing function, right? Now in case 1, the function behaves like an increasing function. So let's solve the inequality. Log x minus 2 to base 1 minus x greater than equal to minus 1. Now the function is increasing in case 1. That means we can write x minus 2 greater than equal to 1 minus x to the power minus 1. So here it will be like x minus 2 minus 1 by 1 minus x greater than equal to 0. So let's take LCM. Here. So it will be x minus x square minus 2 plus 2x again minus 1, that is greater than 0. Okay. Now here it will be 3x minus x square minus 3, 1 minus x greater than equal to 0. Okay. Now let's do one thing. Let's multiply in numerator and denominator by 1. So it will be x square minus 3x plus 3 divided by x minus 1 greater than equal to 0. Now here see, there is a quadratic term. And in this quadratic term, the determinant is less than 0. That means 3 square minus 12, so minus 3. So determinant is less than 0. That means this is always positive. So we can ignore this term. So with simplicity, it will be the critical point here will be only one critical point, that is 1. So positive, negative. So the answer of this part will be greater than 1 to infinity. But what is the initial condition that we took? The initial condition was x should be less than 0. But we got the answer as x is greater than 1. But it was supposed to be x should be less than 0. So there is no common part. That means in case 1, the solution is x belongs to 5. We have not got any value of x in case 1. Let's take the second case. The second case is base should be lies between 0 to 1. Here the base is 1 minus x. So let's take case 2. Case 2 here, base was 1 minus x. So 1 minus x should lie between 0 to 1. That means in this case, the function will behave like an decreasing function, right? So now if I find the value of x from here, it will be minus 1 minus x 0. Let's multiply with minus, the inequality get reversed, then it will be 1 x 0. So this is basically x greater than 0 and less than 1. So and in this condition, the function behaves like an decreasing function. Okay. In this case, x minus 2, that will be, in this case x minus 2, that will be less than equal to x minus 2. In this case, x minus 2, that will be less than equal to 1 minus x to the power minus 1. The inequality get reversed. Okay. So here it will be x minus 2 minus 1 upon 1 minus x that is less than equal to 0. Now let's simplify the equation. It will be somewhere in the last case we have done it only, x square minus 3x plus 3 divided by x minus 1, but here less than equal to 0. Okay, so again this part is positive, always positive, so the answer of this part will be positive, negative. So this is minus infinity to 1, minus infinity to 1, but the initial condition was 0 to 1. Initial condition was 0 to 1. 0 to 1. So this is the common part here. This is the common part here. That is x belongs to 0 to 1. X belongs to 0 to 1. But okay, if we combine these two answer, that is case 1 and case 2, because whenever we make cases we need to take the union of both the answers. So the final answer of these two cases is, one is x belongs to 5, other is x belongs to 0 to 1, that is x belongs to 0 to 1. Okay, x belongs to 0 to 1, that is x belongs to 0 to 1. But there is another condition we need to take, that is the domain of the log function. Whenever there is a log function, we need to define the log. Okay, and how do we define a log? See, if there is a function that is a log function, for that function the number should be always positive and a should be always positive and a should not be 1. Now already we have already considered this about the base, right? Now we need to check about number, and here the number is x minus 2. So the x minus 2 should be positive. That means x should be greater than 2. So here the answer is saying x should be greater than 2, and initially we got this answer. So the intersection of both the answer will be 5. So x belongs to 5. This is our final answer. Because we need to define the log terms. Initially, after doing case 1 and case 2, we got the result as x belongs to 0 to 1. Again, we need to define the log terms. So when we define the log terms, we got the final answer as x belongs to 5. That is our final answer.